So remember, when you're watching these videos, you should be taking notes, writing all of this down. Make sure you are putting a title to the notes you're taking. So what we're going to go over in this video, two topics, okay, graphing lines, and then we're going to go over simplifying and evaluating expressions. So first up is graphing linear equations. Okay, so we're just graphing when we're going to go over the two main forms that we use to graph. Okay, remember, if you have a line, okay, what makes a line? Two distinct points. Two of the most common ways that a linear equation is represented is first through slope-intercept form. When you're in slope-intercept form, it looks like this: y equals mx plus b, where m is the slope and b is the y-intercept. Okay, and the second is called standard form. When you're in standard form, it looks like this: ax plus by equals c. A, b, and c are real numbers. And what you can do when you're in standard form is you can quickly get the x-intercept and the y-intercept. Now, what's the x-intercept? What's the y-intercept? When you have a line, I'm just going to draw any random line here, okay? Here's my line. This is the x-axis, this is the y-axis. Where your line, the point in which the line hits the x-axis, is called the x-intercept. What's special about this point is that the y-coordinate is always 0. And this is called the y-intercept. What's special about the y-intercept? Well, it's just where your line hits the y-axis. And there's something that's always true about when you're on the y-axis. That point always has an x-coordinate of 0. Okay, so these are the two main forms that we're going to graph in: slope-intercept form and standard form. So when graphing in slope-intercept form, we'll start there, okay? Then we'll move to standard form. Okay, so graphing when we're in slope-intercept form, how are we going to graph it? Okay, whoops. First thing we do is we identify the slope. Whoops, sorry. Didn't mean to say slope. We identify the y-intercept, right, which will be 0, comma b. We know that, right? This is the y-intercept. This is the slope. Okay, and we graph it. Graph that point. And then we use the slope to find the second point on line. And then we make a line through those points. So let's start graphing. Number 1, we'll graph y equals 2x plus 1. So one thing is, if you're going to graph using how we graph in slope-intercept form, you need to make sure that your equation is in slope-intercept form. Slope-intercept form is the y variable is isolated. It has no coefficient other than 1, just y. And then you have mx, where x is a variable, right, plus b. Okay, so this is y equals 2x plus 1. Yes, this is slope-intercept form. So the first thing we can do is we can identify what the y-intercept is. The y-intercept here is 1, right? That's the point 0, comma 1. So we can graph that. Okay, now this is the x-axis. This is the y-axis. So that's the y-intercept, okay? Now what's the slope? The slope is the coefficient on x, so the slope is 2. So remember slope, okay? Slope is rise over run, which is the same as saying the change in the y-coordinates over the change in the x-coordinates. So Your slope is how much you're increasing in y over constant changes in your x coordinate. So if your slope is 2, that's the same as 2 over 1. So we're going to go up 2, and we're going to go right 1. So up 2 units, right 1. And if I wanted to plot another point, I could go up 2 more and right 1. Or I could go down 2 and left 1. That's the same. Okay? And then put a line through the points. There's our line. Notice the slope is positive. That's why as x is increasing, y is increasing. Okay? Number 2, we can do y equals negative 3/4 x plus 5. Okay? So notice it is in slope-intercept form. So the first thing we could do is identify what's the y-intercept. The y-intercept is 5. Okay, so we can plot that. The y-intercept of 5, 1, 2, 3, 4, 5. And now what's the slope? The slope of this line is negative 3/4. So what that means is we're going to go down 3, and then we're going to go right 4. When your slope is negative, only one of these movements should be a negative movement. So you shouldn't be going down and to the left, because that's a double negative. Okay? Change in y or change in x has to be negative, and the other has to be positive when it's a negative slope. So if you're going to go down 3, then you have to go the right 4. So down 3, 1, 2, 3, and right 4. 1, 2, 3, 4. Then connect. I could have gone up 3 and left 4. I would have been at a point that's over here. Remember, a line represents, these are all infinite number of coordinate points that when you, if you were to zoom in a line, these are just all coordinate points that form this shape of a line. All of these points that fall on this line are what make this equation true. So if you pick any coordinate point that falls on a line, x comma y, and you plug it into this equation, it will always make the equation true. If a point, if you picked any random x comma y coordinate, like this point right here, it's not on this line. So if you were to plug in the point 2 comma negative 1, it would not make this statement a true statement. Okay, so that's what you graph, because it's a graphical representation. Okay, it's a visual representation of all of the points x comma y that if you were to plug them in, make the equation true. So let's just do a few more of these before we move on to standard form. Number 3. y equals 4x minus 2. Notice this is not in slope-intercept form. So the first thing is we have to put it in slope-intercept form. So we need to get y by itself. So this would be y equals 2x minus 1. So now we can graph. We identify what's the y-intercept because now we're in slope-intercept form. The y-intercept is negative 1. Okay, and the slope is 2. So that means we're going to go up 2, and we're going to go right 1, up 2, right 1. If we want another point, up 2, right 1, or down 2, left 1. Notice if they're both negative, that's the same as being positive. Okay, notice as x is increasing, y is increasing. Okay, number 4, what about y plus 3 equals negative 4x plus 3. So not in slope-intercept form yet because we do not have the y isolated. So to get y isolated, if it's y plus 3, we have to take away 3. And that's going to give us y equals negative 4x, which is the same as saying y equals negative 4x plus 0. Notice these two statements are equivalent. Okay, they have the same exact value. Adding 0 to something does not change its value. Now, this might help you a little bit more because when people see this, they forget, they freeze up. This is still technically slope-intercept form. The y-intercept is 0. Okay? And then what's the slope here? The slope here is -4. So that means that's -4/1. We have to go down 4 and then right 1. So we have to go down 4, 1, 2, 3, 4, right 1. And notice the slope is -4. That's why as x is increasing, y is decreasing. Your negative slope, you are falling as x increases. That means as x is getting bigger, your y's are getting smaller, more and more negative. Okay, so when you're in slope-intercept form, first thing is you check to make sure that you are actually in slope-intercept form, which is y equals mx plus b. You then identify what your y-intercept is, you plot that point. You identify what your slope is, you use the slope to plot a second point, and then you connect and you make your line. So now, let's get into standard form. Oops, sorry. Standard form looks like this. If you want to get your x-intercept, you set y equal to 0, okay? So ax plus b times 0 equals c. That's going to give you ax equals c. So then we just get x by itself, and that's our x-intercept, okay? Our x-intercept. To get our y-intercept, we set x equal to 0. So it's going to look like this when we do the work. Now, the x-intercept and the y-intercept are not the same point. These are two separate points. Notice, a times 0, that just goes away, just like b times 0 does. So this would be by equals c. The y-intercept is c over b. Okay, so the reason, standard form, you don't need to put this in slope-intercept form because when you're in this form, it's quick to get your intercepts. And remember, a line, you only need 2 points. So if you have 2 distinct points, you can make a line. X-intercept, y-intercept, most of the time they're distinct points unless they share the point 0, 0. Okay, so if you have both of these points that are distinct, you have enough information to make a line. So you might want to graph in standard form just using this method, okay, and not trying to put this thing in slope-intercept form. So if it was, let's say, 2x plus 4y equals 8, okay, this is what we have to graph. So to get our x-intercept, notice it's got the x and the y on one side and the constant on the other. To get the x-intercept, you let y be 0. So that's going to be 2x plus 4 times 0 equals 8. 4 times 0 is 0, so that's gone. That's going to be 2x equals 8. Divide by 2, and x equals 4. So the x-intercept is 4. So here's your x-axis, here's your y-axis. This has an x-intercept of 4. Now we get the y-intercept. That would be the point 4, 0. Okay? To get the y-intercept, which is where is this line going to hit the y-axis, you set x to be 0. So 2 times 0 plus 4y equals 8. This goes away. Positive 4y equals 8. So y equals 2. So the y-intercept is 2. Okay? The y-intercept is where do you hit the y-axis? That's the same as the coordinate point 0, 2. So now, since they're distinct points, there you go. Quicker than trying to put this in slope-intercept form. Okay, number 2. 3x minus 4y equals negative 12. So, actually, let's change this a little. Let's do 3x minus 6y equals negative 12. Okay? So, notice this is in standard form, so a quick way to graph this is using the x and the y-intercept to plot points. So we're going to get the x-intercept, then we'll get the y-intercept and plot those 2 points. So to get the x-intercept, you let y be 0, because your x-intercept is where are you hitting the x-axis. So set y to be 0, so 3x minus 6 times 0 equals negative 12. This goes away. That gives us 3x equals negative 12. Divide by 3, and x equals negative 4. So the x-intercept is negative 4, which is the same as just saying that that point's name is negative 4 comma 0. And the y-intercept, we let x be 0, so it's going to be 3 times 0 minus 6y equals negative 12. This goes away. Notice what you still have. You have negative 6y equals negative 12. Divide by negative 6, and y equals 2. So you plot that and connect. Okay, the y-intercept is 2. That's a point 0, 2, and there it is. So when you are in standard form, there's a quicker way to graph than trying to put it into slope-intercept form. You can just get the x-intercept and get the y-intercept and plot to those points. These don't always have to be integer values. They could be decimals. Okay? You can have decimal values. They don't always have to fall right on the tick mark. They could fall between, anywhere between. That's fine. But those are the two ways that you graph: slope-intercept form and then standard form. Those are two of the, I'll say, most common ways. But let's go over special lines before we go into simplifying expressions, okay? So special lines. We've got vertical lines and we've got horizontal lines. Those are special lines. So when you have vertical lines, okay, an example of a vertical line would be I'll draw it in a different color. I will put it in red. This vertical line right here, okay? A vertical line indicates that the x-coordinate is staying constant. The equation of this line would be x equals 2. So what this means is that no matter, it doesn't matter what y is, but x is always the value of 2. So when you have a vertical line, you always have, your equation is always x equals a, where a is a number, okay? And so let's say if I did in green, okay, that's the line, x equals 2, and this is the line. If I drew this vertical line, the equation of this vertical line is x equals negative 3. So when x stays constant, it says x is equal to negative 3. Doesn't matter what y is, it's a vertical line. When you have a vertical line, you've seen this in Algebra 1, your slope is undefined. Okay? A horizontal line is different than a vertical line. A horizontal line looks like this. The equation of that green line, y is staying the same. Y is always 1, okay? If I drew another one, horizontal line, the equation of this line would be y equals negative 4. So when you have a horizontal line, its equation is y equals a, where a is just a number. And in this case, when you have a horizontal line, the slope is the value of 0. So it exists, okay, and the slope's value is 0. Because remember, slope is talking about how much you're rising as you go over a certain amount of x, constant value of x. You are infinitely going up and never going over for a constant value of x. So you can't calculate the slope. Here, you're not going up as you go over. So the slope here is 0. So those are your two special lines to keep in mind, your vertical lines and your horizontal lines. So now we're just going to move on to simplifying expressions and evaluating expressions. So when we simplify expressions, okay, we need to make sure that we combine like terms. So when we combine like terms, right, that means that they have the same variable, they have the same exponent, okay? So we'll just simplify two expressions. So if we had 2x squared minus 4x plus 5x squared plus x minus 3. And we were told to simplify this expression, okay? So you want to look to see if you just have an expression, how we can combine like terms. So like terms, 2x squared and 5x squared are like terms because they have the same variable raised to the same exponent. So that is going to give me 7x squared. And then I've got a negative 4x and a positive 1x. If I combine those, that would leave me with negative 3x. And I don't have anything to combine that with. So my simplified expression would be 7x squared minus 3x minus 3. Number 2, if I had negative 7y plus 7x minus 4y squared plus 8y. Okay, you can only combine like terms. So if we notice, we have no like term with negative 4y squared. We have no like term with positive 7x, but we do have one pair of like terms here. We have negative 7y and 8y, and that's going to put us at positive 1y. Okay, so remember, they have to have the same variable, and they have to be raised to the same exponent if they're going to be like terms. And lastly, if we're going to evaluate an expression, okay, let's go over two expressions. Number 1, let's say negative x squared plus 5x plus 1, and we're going to evaluate when x is 2, okay? So I'm going to plug 2 in, but you have to be super careful here. Notice, this says take x, square it, and make it negative. So if we evaluate this, okay, that means we plug 2 in for x. This is how we should be evaluating. The negative is out here, okay? It does not go inside. This says take x square, make it negative. So this is 2 squared is 4. So this is negative 4 plus 10 plus 1. Negative 4 plus 10, that's going to be 6 plus 1. So this evaluates to be 7. Let's say we evaluate this when x is negative 2. Okay, so it would look like this. Negative negative 2 squared plus 5 times negative 2 plus 1. Negative 2 squared, that's going to be 4, but it's still negative because it says take this, square it, and then make it negative. 5 times negative 2 is negative 10. Okay, negative 14 plus 1, that's going to put us at negative 13. Okay, and let's evaluate one more expression. Number 2, let's do a squared plus 5b over c. When a is negative 3, b is 2, and c is negative 1. Okay, so we're going to plug it in. So we're taking negative 3 and squaring it, right? So negative 3 squared plus 5 times b, which is 2, all over c, which is negative 1. Remember, you have to follow your order of operations. So first thing, exponents here, negative 3 squared, that's going to give us positive 9. 5 times 2, that's going to give us 10, all over negative 1. Do the numerator, 9 plus 10, 19 over negative 1. That simplifies to be the value of negative 19. So just be very careful. Make sure you follow order of operations, okay? Make sure you are evaluating correctly, taking negative 3 and squaring it. This time negative 3 is completely in parentheses because that's the value of a. It's being squared. We have no negative sitting outside. This is when the negative is outside here. Okay, so that is it for graphing lines and simplifying expressions.